Determine the area which is between the curves y equals 2 sine x and y equals minus 3 cos x over the closed interval from 0 to pi by 6. Okay? So we've got two curves, we've got an area. We do have bounds here, which is good because sine and cosine, they weave in and out of each other. There's tons of little areas there, but visualizing this, because drawing a graph is a great way to get a sense of this problem. So we've got sine, but sine is being stretched by 2. So it starts at 0, and normally it would go up to 1, but it's actually going all the way up to 2. And then by pi, it's back down, and then it stretches all the way down to minus 2. Could even put these things on here if we really, really want to. And then it'll keep doing that. Cosine starts at 1, but we're doing minus 3 cosine. So we're actually going to start all the way down here. And so cosine normally would be like this, but since we're doing minus 3, we're reflecting it, so it's like that. So it'll be down here. And when sine reaches its peak, we reach our lowest, and then we go up here to 3. But since this happens at pi by 2. Okay? Pi by 2 is where sine reaches its peak. But we don't even need all of this out here. We're going from 0 to pi by 6. So 0 is here. Pi by 6 is about here. In fact, it's probably a little closer. And so we just want this area here. Okay. And so we have a formula. We take the top function minus the bottom function and integrate to set up your definite interval. It's fantastic. And we can see clearly with this graph that we can just see, okay, the 2 sine is the bigger one because cosine starts all the way down here in the negatives, the minus 3 cos x there. All right, so I think we could probably squeeze it in. I don't need to resort to a separate piece of paper. So we take the bigger function minus the smaller function, but minus 3 is just going to be plus 3, so we'll have plus 3 cos x. And now we need antiderivative. So antiderivative of sine is minus cosine, so we'll get minus 2 cosine. Antiderivative of cosine is sine, so we get plus 3 sine. And we plug in pi by 6 and 0, and we know our trig functions and their special values. So we get minus 2 cosine of pi by 6 is root 3 over 2. Sine of pi by 6 is 1/2. And then minus, and now you come along, you plug in 0. So minus 2 times cosine of 0, so that's minus 2 times 1, plus 3 times sine of 0, so that's 3 times 0. So 2 here and 2 here will cancel out. We'll have 3 halves minus root 3 minus negative 2, so that's really plus 2, and then we can ignore the 0. So 3 halves plus 2, well, that's 3 halves plus 4 halves. So we get 7 halves minus root 3. Or if you wanted to introduce the half again, you could say 7 minus 2 root 3 over 2 if you wanted a more condensed answer. But I like this with my rational part and my square root part sort of separated. Either or, frankly, is fine. You're expressing your answer nice and fairly simple there. So I didn't need an extra piece of paper there. But yeah, quick graph to figure out who's on top, and then integrate between the given bounds there.